class we will focus on applications of short-term decisions. So we will try to understand how we can apply the traditional formula to deal with short-term decision, which is net operating income as the difference between sales revenue and cost, in order to understand some examples of these applications. Basically, in this class and then in the following ones, we will investigate 3 different examples of applications. The first one is the break-even point analysis, the second one is the analysis of the production mix, while the third one is the alternatives evaluation. Let's start in this class with one traditional example of applications of short-term decisions, that is the break-even point analysis. When we deal with the break-even point analysis, the problem is to identify the quantity to break even, which is the quantity at which total costs equal total revenues. So the main question is how many units should the company be able to produce and then sell in order to break even. So it is the quantity at which total costs equal total revenues. And we will try to understand how we can approach this kind of problem. As I said, given that still we are dealing with short-term decision, our starting point is always the same, net operating income as the difference between revenues and costs. We can be even more precise in this formula, defining the revenue as the product by price by the quantity. So we can say that the revenue is given by the price of our product multiplied by the quantity minus the total costs, where the total costs are the difference between variable cost, the unitary variable cost, multiplied by the quantity minus the fixed costs. We have just rewrite this formula by expliciting the revenues and then the cost. If we want to identify the quantity at which total revenue equals total costs, we just need to set this formula equals to 0. So if we say that this NOI should be equal to 0, we can then isolate the quantity, and this quantity will be the quantity at which this total revenue equals the total costs. So if we solve this formula by Q, that we define quantity to break even, we will have that the quantity to break even will be equal to the fixed cost divided by the price minus the variable cost. We have just solved this formula with respect to Q. In this way, the value that we obtain is that quantity at which total revenue equals total cost. We can also plot this formula so that we can graphically visualize the quantity to break even. In our plot, we can have the following. We will have the quantity on the horizontal axis, while we will have both total cost and then total revenues on the vertical axis. Let's start by plotting the total revenue. The total revenue is given by the price multiplied by the quantity. So if the quantity equals to 0, the total revenue will be 0. So the starting point will be this one. The more we are selling, the higher the total revenue. So the shape of the total revenue will be the following. We need to do the same with the total cost, but if we look at the formula, we have that even though the quantity equals to 0, we have the fixed cost. So the starting point of the shape of the total cost occurs at the value of the fixed cost. Then we have that the higher the quantity we are producing, the higher the total cost. So basically the shape of the total cost will be more or less something like this. You can see that at a certain point, total revenues equals total cost. So the quantity that corresponds to this point is exactly our quantity to break even. So we have graphically represent the quantity to break even. You can see that the more we are moving from the quantity to break even to the right side of our picture, the higher the difference between total revenues and then total cost. Basically, this delta represents our net operating income. So the more we are moving to the right side, the higher the net operating income that we can generate. The lower the quantity with respect to our break-even point, the higher the value of the total cost with respect to the total revenue. So in this area, we have a loss. We can also add something more, because by looking at this picture, we can say that in the moment in which we want to achieve a certain net operating income, still we can define the quantity that allow us to achieve that specific net operating income. How? If instead of setting this formula equals to 0, we set this formula equals to a certain net operating income, which is our target, our quantity to break even will become the quantity to break even in order to achieve a certain net operating income will be equal to the fixed cost plus our target net operating income divided by the price minus the variable cost. Basically, we have identified this quantity, the quantity to achieve a certain net operating income. So we can just readjust the formula and isolate the specific term that we need depending on our problem. But the main reference element is exactly the quantity to break even, so the quantity at which our total cost equals total revenue. This is particularly useful for a company because once we have identified the quantity to break even, we know exactly the quantity that allows the company to generate a profit or to generate a loss. We should add something more when we deal with the break-even point, because if you look at the formula, we use the same quantity either for the revenue and as well for the cost. So basically, we can apply the quantity to break even if some conditions exist. The first condition is that we need to have just one product. If we just produce one type of product, then we can apply the quantity to break even formula. The second characteristic is that we do not need inventories because the quantity that we sell is equal to the quantity that we produce. So the second characteristic is that we need to sell exactly the same amount that we produce. But it is feasible if we think of short-term decision, given that we are planning in the short term. So we can plan something in order to not to have inventories. The other characteristic is that we need that both revenues and cost remain constant over time, which means that the price should remain the same as well as the variable cost. Again, this assumption is quite reasonable given that we are reasoning in the short term, so we can assume that in the next few months the price wouldn't change, and the same happens with the variable cost. So these are the assumptions that we need to take in mind if we want to apply the break-even point. So if we go back to our reference schema, we can say that in the moment in which we have our break-even point and our problem is define the quantity to break even, the approach in order to deal with this problem is to identify the quantity to break even as the ratio between the fixed cost divided by the price minus the variable cost. So that's the approach that we can use in order to solve the break-even point problems.